right? Okay. So students, how many types of motion are there? Yes, anyone? How many types of motion are there? Hmm? No one knows?
Circular, straight,
Straight line, linear motion, very good. Second, circular
circular,
motion. Any other?
Fourier oscillation,
Random motion.
Oscillatory motion, very good. Oscillatory motion, right? And there is a fourth type of motion which actually includes all them, like all the motion. So we call it random motion, right? If an object moves in all these three types of motion, what do we call it? Random motion. Okay, let us start. So what is oscillatory motion or vibratory motion? It is to and fro motion of an object about a mean position or central position or equilibrium position, right? Okay, so the examples are like, let's say we have a ball here and it is sliding down a ramp, and then it is like moving up the ramp and then it is coming back. Or the next example is like this. We have an object of mass m which starts vibrating connected to the spring, or thus we have a pendulum, right? So these are all the examples of oscillatory or vibrating motion. Okay, students. Now, what is free oscillation and what is an undamped oscillation? Free oscillation is basically also called undamped oscillation. What is undamped oscillation? In which no energy is lost. So the oscillation of the body in which its own natural frequency and under no external influence or no energy loss or no change in amplitude, this is called what? This is called undamped oscillation. It is like, it is gonna be looking like this. So stress, there is no change in amplitude basically, right? No change in amplitude. Right? But if there is a damped oscillation, then there will be definitely a clear change in amplitude. Like energy will be lost. Right? So this is called damping. What? Damping. Okay, now next thing is restoring force. A force due to potential energy. Due to potential energy stored in an object, and it acts on an object when it undergoes deformation. This is called restoring force, right? Body with stored energy. Like if let's say this is a mean position of the spring, then is there any elastic potential energy stored in the spring right now or not when it is unstretched?
no,
Yes, would there be any energy stored if it is unextended?
unstretched, yeah, unextended तो फिर नहीं होगा ना sir.
नहीं होगा, right? Okay, if it is compressed, would there be any energy stored?
Yes,
Energy will be there, right? And if it is stretched, then
yes,
energy will be there stored in it, and that energy is what? Elastic potential energy. So what do you think, students, in this, like this is, let's say, first case, this is second case, and this is, let's say, third case. What do you think in the second case, if let's say we have compressed the spring and we just release the mass, or like let's say we don't release it, I'm just holding it at this position, then in which direction the spring will be applying the force on the mass? Yes.
left, no, on the right,
Towards right. Towards right. So that is restoring force. F restoring, right? And what about when the spring is stretched? In which direction it will be like applying force on mass M?
left,
towards left. So we'll be calling that force as restoring force, right? Okay, now let's talk about some other restoring forces. Like what about this pendulum when it is here? So students, its forces will be like weight and tension, right? So we'll be making the components of the weight, and the first component of the weight will be this. It will be W cos theta. If this is theta, and students, what will be this component? This will be W sine theta, right? So students, W cos theta will be cancelled by tension. So W sine theta will bring this object, brings pendulum back to the mean position, brings the pendulum back to its mean position. Right, students? So, okay. Sadik, so to nahi raha?
No, sir.
वाह जी उठा हुआ है लेक्चर अटेंड कर रहा है ना
Yes, sir.
गुड गुड सादिक इस दफा अच्छा ग्रेड आना चाहिए अक्टूबर नवंबर में करना है या मई जून में
सर अक्टूबर नवंबर से आप टेंशन ना ले मेरा है क्या तैयब कभी अच्छे ग्रेड आ गए
अच्छा तो ये
तैयब
कर
शान का ये शान का देखना क्लासेस मिस कर रहा है काफी
ये तैयब ऐसे ही करता है जिस दिन आप नहीं ना आते शान के साथ हो जाता है जिस दिन शान नहीं आता आपके साथ हो
बस सर देख ले सर
सर मैं तो लेता हूँ क्लासेस से
ओके जी ओके due to stored energy a force compels the body to vibrate and we call it what restoring force right okay so there are the characteristics of the vibratory motion students you know if we talk about this pendulum then this is called mean position right and these two positions the most largest distance position these are called what extreme positions right first thing okay this is also extreme position and if we like want to compare it with a wave oscillating wave then students this is mean position and these two are extreme positions this negative extreme and this is positive extreme position right okay so the definitions are written here okay next displacement you know students displacement is represented by x so it is the distance of a particle from mean position what is amplitude it is x naught or it is represented by capital A. So it is the maximum displacement from mean position. Time period is represented by capital T. It is the time to complete one oscillation. So you already know about it. Frequency is students number of oscillations per unit time and its formula is what? N divided by time and for one oscillation, what happens? One oscillation N is 1. So T becomes the time period. So formula becomes F equals to 1 by capital T. Which is also correct, right? What about angular frequency? It has the same formula that as it was having in the previous chapters, 2 pi f or 2 pi by capital T, right? So, or we also call it like theta divided by T, right? Okay. So what will be its SI unit of omega? Definitely it will be same that radians per second, right? Okay. Next. Let's go into the detail of simple harmonic motion students. Let's say we have this spring and it is initially unextended, unstretched, or it is like uncompressed. And this is mass M, which is at rest. So students, there is no kinetic energy, there is no elastic potential energy. And if we talk about like displacing this mass, and bringing it to that position, let's say, that position, right? Okay. Or a little further, like let's say here, right? So what will be happening to the spring? Spring will be stretched. So spring will be looking like this, right, Shreya? So let's say the extension is like this. Here is the extension. Let's say here is the extension. So restoring force like spring will be pulling the mass towards itself, towards its main position. So here will be the restoring force, right? Here is the mass M, here is the applied force, right? So let's say the mass is still at rest. So kinetic energy is still zero. Kinetic energy is still zero. But as there is extension, so there will be elastic potential energy, which will not be zero. It will be rather maximum, right? Okay. So now, let's say now the mass M is released. M is now released. So where will it be start moving? Left or right?
Left.
Definitely left towards the restoring force, right? So students, if I ask you that this mass is reaching here, like let's say from point A to point B, the same mass M, then the spring is now less stretched, right students? Less stretched. So what will be happening to the restoring force here, students? Will it be less or more?
Less.
Very good, less. Restoring force will be decreasing, extension will be decreasing, elastic potential energy will be decreasing, so kinetic energy will be increasing. So is the speed, right? Okay. So now my next question is, let's say the object reaches its mean position now, like let's say here. Now the spring will be in its original form, like it will be now looking like this. The original form in which it was released or extended, right? Okay, now what about the restoring force right now?
Zero.
Zero. Restoring force will be zero because extension will be zero. So elastic potential energy will be zero. So velocity will be maximum. Hence the kinetic energy will be maximum. So all the elastic potential energy is converted into kinetic energy, right? Will the object keep on moving or it will stop here?
Keep on moving.
Keep on moving towards left, right? So here is the motion. So we'll be saying M keeps moving due to inertia or momentum, right? Okay, so it will, if it keeps on moving, then what about when it reaches a point, let's say here. Now students, the spring will be compressed basically. Okay. So spring will be compressed and let's say the mass is keep on moving, it is not stopping, then what is going to happen? Now the X is increasing, EP is increasing, velocity is decreasing, kinetic energy is decreasing. And what about X? Yes.
Negative. It's
X is negative. X
decrease.
is becoming negative, right? So what about restoring force? What will be the direction of the restoring force now? Yes, students. What will be the direction of the restoring force? Now the spring is being compressed here. Compression is towards left. To restore that compression, spring will push the mass where?
To the right.
Towards right. Right, and let's say now the spring is fully compressed when the mass reaches this position. And the spring looks like this. Right, fully compressed, and then this mass comes to rest. So X will be maximum. Maximum will be the elastic potential energy. Maximum will be the restoring force. And kinetic energy will become zero because the velocity is zero, right? So this is all what's happening. Now, let's talk about it. Yes, friends. Let's say this is our applied force and this is restoring force. Tell me, if I apply more force to stretch this spring more, the restoring force will be increasing or decreasing?
Increasing.
Increasing.
Very good. So I'll be saying that applied force is equal to restoring force, but opposite in direction. And students, applied force is given by what? It is given by Hooke's law, Kx equals to negative F restoring, or F restoring is equal to negative Kx, or every force is equal to what, students? Every force is equal to what? Ma. And if I make A the subject to the formula, so it will become what? Negative K by M times X. So that's the formula of simple harmonic motion. Right? And how do we say it? Like, what about, students, this K and M? K and M both are constant, so this whole thing is constant. So I can write it like this: A is directly proportional to negative X. What does it mean? A is proportional to X means they are directly proportional, and A is proportional to negative X means K direction is what? Same or opposite?
Opposite.
Opposite, right? And A is proportional to X means A is directly proportional to X. Right, students? Okay. So this is how we define simple harmonic motion, students. A simple harmonic motion is a vibratory motion due to restoring force in which acceleration is directly proportional to the displacement from mean position, and it is also directed towards the mean position. So students, what's the graph then? The graph is like this: A equals to negative K over M into X. So if I compare it with like Y equals to MX plus C, so it will be saying us that the y-intercept is what? Y-intercept is 0, so the graph will be passing through origin, and the gradient will be what? Negative or positive?
Negative.
Negative, right? So the graph will be looking like this: a line passing through origin with negative gradient. The graph between A and X. Right? A acceleration and X displacement. Right, students? So gradient of the graph, gradient will be, students, this equals to negative K over M. So it will be equals to definitely A by X, right? Okay. In simple harmonic motion, so acceleration is not constant. It is not constant. as it is directly proportional to the displacement. So displacement is not constant, so acceleration is also not constant. So students, who will tell which motion is simple harmonic, the left one or the right one?
Right.
Right one. Okay. Shwet Shah told us right. Hadi. Yes, Hadi. Hadi, are you there? I can't listen to you.
So
Curved wala. Okay. Tayyib. Yes, Tayyib. जी
सर क्वेश्चन रिपीट करना.
मैंने पूछा राइट वाला मोशन सिंपल हार्मोनिक है या लेफ्ट वाला?
सर राइट.
राइट वाला. मिशा, व्हाट डू यू से?
The right one.
राइट वाला. ओके. सादिक. यस, सादिक.
Sir, right.
सबने कह दिया राइट वाला. अब एक्सप्लेन कौन करेगा? हादी एक्सप्लेन करेगा. कैसे राइट वाला सिंपल हार्मोनिक? जी हादी. और लेफ्ट वाला क्यों नहीं है? जी. यस स्टूडेंट्स.
सर लेफ्ट में एंगल है इसलिए.
लेफ्ट में एंगल है तो राइट में एंगल नहीं है. राइट में एंगल नहीं है. बहुत अच्छे भी.
नहीं, राइट में कांस्टेंट चेंज इन एंगल, यहाँ पर डायरेक्ट चेंज इन सडन चेंज इन एंगल.
तो एंगल चेंज होने का क्या मतलब है?
उसके कंपोनेंट्स भी चेंज होते हैं ना फिर.
तो फिर क्या चेंज होगा?
उसका एक्सेलरेशन.
वेरी गुड. वेरी गुड. सो ये आ गया जी हमारे पास वेट. ठीक है. ये लेट्स से एंगल थीटा है तो वेट के क्या बनेंगे? कंपोनेंट्स बनेंगे. लाइक लेट्स से दिस इज w cos थीटा एंड दिस इज w sin थीटा. ठीक है. अब नॉर्मल कांटेक्ट फोर्स भी ऊपर लग रही है. अच्छा, अब क्या क्या हुआ जी? नॉर्मल कांटेक्ट फोर्स और w cos थीटा वो तो कैंसिल हो गए. अब रह क्या गया? w sin थीटा. यानी नेट फोर्स किसके इक्वल होगी? w sin थीटा. गुड. नेट फोर्स किसके इक्वल होती है जी? नेट फोर्स होती है जी ma के इक्वल. और W क्या होता है? mg. तो क्या कैंसिल हो गया जी? mm कैंसिल हो गया. तो हमारे पास एक्सेलरेशन क्या रह गया? g sin थीटा. ठीक है. अब g भी कांस्टेंट है और थीटा भी कांस्टेंट है. तो फिर a भी क्या हो गया? कांस्टेंट हो गया. और अभी मैंने आपको बताया बच्चों, एक्सेलरेशन तो कांस्टेंट रहता ही नहीं. ये क्या लिखा हुआ? एक्सेलरेशन इज नॉट कांस्टेंट. ठीक है. एक्सेलरेशन इज नॉट कांस्टेंट. तो यहाँ पर आप देखिए फॉर्मूला बिल्कुल वैसे ही आएगा. a इज इक्वल टू जी साइन थीटा. बस इसमें क्योंकि थीटा वेरी कर रहा होगा तो एक्सेलरेशन भी क्या करेगा? वेरी करेगा. सो एक्सेलरेशन इज नॉट कांस्टेंट. सो क्या लिखेंगे अब? इट इज नॉट SHM और इट इज SHM. ठीक है स्टूडेंट्स. एवरीवन गॉट इट और नॉट? यस. Students, everyone is getting it?
Yes, sir.
Okay, good. So let's go further. Okay, students. So who will tell this? Explain whether a bouncing tennis ball in gravity on Earth an example of simple harmonic motion or not? Yes. Yes, students. Is it an example of SHM or not? A bouncing tennis ball or a bouncing ball, any ball?
Yes, sir.
Yes?
Yeah.
Okay, you are saying yes. Okay, Hadi, what do you say?
Yes.
Yes. Sadek,
I think so, sir.
you think so? Misha, do you think so?
I don't think so.
Very good. Misha is right. It is not simple harmonic motion. So why, Misha? Why it is not simple harmonic motion?
Its acceleration is constant on Earth.
Very good. Very good. As acceleration is constant. That
सर
is
वो नेगेटिव और पॉजिटिव नहीं होती ऊपर जब ऊपर जा
ये
रहा होता है नीचे जा
मैग्नीट्यूड
रहा
की
होता है
बात करेंगे मैग्नीट्यूड की बात करेंगे कांस्टेंट दैट इज प्लस माइनस 9.81 या तो प्लस 9.81 होती है या माइनस 9.81 होती है इसका मैग्नीट्यूड नहीं चेंज होता देखे ना ए का फॉर्मूला क्या है ये है इसका मतलब ए का मैग्नीट्यूड भी एक्स के साथ चेंज हो रहा है या नहीं ए का मैग्नीट्यूड चेंज हो रहा है या नहीं
यस
बिल्कुल देखिए ना x1 है a1 हो जाएगा x2 है a2 हो जाएगा x3 है a3 हो जाएगा तो मैग्नीट्यूड भी चेंज हो रहा है साथ साथ ठीक है लाइक ये -1 -2 -3 हो जाएगा राइट ओके so students next is simple harmonic motion and uniform circular motion अच्छा आप जरा गौर से सुनना let's say it's the top view of something which is what okay students so this is the top view and the light is coming from there and the object is rotating this is rotating object and the light is coming from here so its image if you see the image of this rotating object on a wall or screen then students you will be coming to know that this shadow will be moving up and down and this up and down motion is students simple harmonic motion and this is basically uniform circular motion right so uniform circular motion and simple harmonic motion they are same they are what same uniform circular motion and simple harmonic motion they are same right okay so students whatever are the properties of uniform circular motion they are going to be the properties of simple harmonic motion so it is clear that the shadow of uniform circular motion is simple harmonic motion right so whatever if the time period is in uniform circular motion then the time period is same for simple harmonic motion if the frequency is 1/t there then the frequency is 1/t here And if the angular velocity is 2 pi f there, 2 pi by t there, then it is going to be 2 pi f here and 2 pi by t here. But its name is changing because right now it is not angular velocity, it is rather angular frequency. So that's the only change, first change, right? Right, students? So what is omega here? Angular velocity. What is omega here? In the simple harmonic motion, it is angular frequency, right? So if this is radius r here, then it is amplitude a here. A or x naught, right? And if the velocity a v is equal to r omega is here, then the velocity is a omega here. And if the acceleration is r omega square here, then the acceleration is x naught omega square or a omega square. But there will be a what sign? A negative sign. So that's the difference.
यस सर.
Yes?
सर ये यूनिफॉर्म सर्कुलर मोशन में तो हमारी एक्सेलरेशन कांस्टेंट नहीं होती.
Very good. यही तो अब डिफरेंस है ना. यही तो डिफरेंस है कि यहाँ पर r जो है वो कांस्टेंट है. ये डिफरेंस आ गया ना. बाकी सिमिलैरिटीज है, ये डिफरेंस है. सो एक्सेलरेशन भी कांस्टेंट हो गया. यहाँ पर जो है इसकी जो मैक्सिमम वैल्यू है ना वो ये है. ये मैक्सिमम वैल्यू है. इंस्टेंटेनियस वैल्यू क्या होगी? a इज इक्वल टू माइनस एक्स ओमेगा स्क्वायर. ठीक है. तो x चेंज हो रहा होगा तो फिर a भी क्या होगा? चेंज होगा. ठीक है आदि. ओके जी. फॉर्मूला ऑफ सिंपल हार्मोनिक मोशन. अदर फॉर्मूला फिर यही आ गया ना. a इक्वल्स टू नेगेटिव ओमेगा स्क्वायर x. ठीक है. तो फिर ये वही बात आ गई कि अगर मैं इसको कंपेयर करूं y इक्वल्स टू mx प्लस c से, तो इस दफा थोड़ा चेंज हो जाएगा. लाइक y इंटरसेप्ट तो अभी भी 0 है. y एक्सिस पे a है. ठीक है. x एक्सिस पे x है. तो फिर लाइन क्या होगी? वही नेगेटिव ग्रेडियंट वाली लाइन होगी ऐसे. ठीक है. बस डिफरेंस क्या है कि इस दफा ग्रेडियंट की वैल्यू किसके इक्वल है? नेगेटिव ओमेगा स्क्वायर का इक्वल है. ठीक है. तो हम यहाँ पर अब एक और काम भी कर सकते हैं. अगर फ्रीक्वेंसी निकालनी है तो ओमेगा स्क्वायर किसके इक्वल हो गया? नेगेटिव ग्रेडियंट. सो ओमेगा किसके इक्वल हो गया? ओमेगा इज इक्वल टू स्क्वायर रूट ऑफ नेगेटिव ग्रेडियंट. ठीक है. और ओमेगा इटसेल्फ किसके इक्वल होता है? ओमेगा इक्वल होता है जी 2 पाई एफ के इक्वल टू नेगेटिव ग्रेडियंट. तो यहाँ से बच्चों आप फ्रीक्वेंसी निकाल सकते हैं और वो क्या होगी जी? नेगेटिव वैल्यू ऑफ द ग्रेडियंट स्क्वायर रूट डिवाइडेड बाय 2 पाई. ऐसे आपकी फ्रीक्वेंसी आएगी. ठीक है जी. ओके. नेगेटिव. अब हम कंपैरिजन करते हैं जी. एक हमारा फॉर्मूला था बेसिक a इक्वल्स टू माइनस k बाय m इंटू एक्स, और दूसरा अभी हमने निकाला है a इक्वल्स टू माइनस ओमेगा स्क्वायर x. तो इसमें अगर हम देखें तो बच्चों a भी सेम है, यहाँ से x सेम है, तो फिर इन दोनों को भी तो सेम हो जाना चाहिए ना. नेगेटिव k ओवर m और ओमेगा स्क्वायर को हम कहेंगे नेगेटिव k ओवर m इक्वल्स टू नेगेटिव ओमेगा स्क्वायर. ठीक है. तो यहाँ से नेगेटिव नेगेटिव कैंसिल हो गया. सो ओमेगा स्क्वायर इज इक्वल टू k बाय m, या फिर ओमेगा इज इक्वल टू k बाय m स्क्वायर द रूट, या फिर 2 पाई f इज इक्वल टू k बाय m स्क्वायर द रूट. और यहाँ से फ्रीक्वेंसी निकालेंगे तो बच्चों वो हो जाएगी 1/2 पाई स्क्वायर रूट k बाय m. अगर टाइम पीरियड निकालेंगे तो वो इसका रिवर्स हो जाएगा, लाइक 2 पाई अंडर रूट m ओवर k. राइट. तो हमें सिंपल हार्मोनिक मोशन की दो कौन सी प्रॉपर्टीज मिली? यस यस.
सर आपने ये x सेम क्यों किया है? क्योंकि उसमें तो x एक्सटेंशन था और इसमें रेडियस है. तो
नहीं, ये सिंपल हार्मोनिक मोशन के हैं. एक मिनट. ये जो मैंने फॉर्मूला बताया था आपको, ये देखे ना, ये सिंपल हार्मोनिक मोशन नहीं है. ठीक है.
ओके.
और यहां पर अभी जो हमने सिमिलैरिटी में देखा है वो क्या है, वो भी हमारा एक्स ओमेगा स्क्वायर है, ये राइट साइड पे नीचे देखें, ठीक है। फिर हमने इन दोनों को कंबाइन कर दिया, कंपेयर कर लिया, ठीक है आदि।
ओके सर।
ओके सो स्टूडेंट्स, पहली प्रॉपर्टी क्या है? पहली प्रॉपर्टी ये है कि एक्सेलरेशन वर्सेस डिस्प्लेसमेंट ग्राफ पासेस थ्रू ओरिजिन। इसका मतलब क्या है कि एक्सेलरेशन एंड डिस्प्लेसमेंट दे आर डायरेक्टली प्रोपोर्शनल टू ईच अदर। ये ग्राफ से मैं बता रहा हूँ। दूसरी प्रॉपर्टी क्या है? ये तो पहली प्रॉपर्टी थी। दूसरी प्रॉपर्टी ये है कि ग्रेडियंट ऑफ द ग्राफ इज नेगेटिव। इसका मतलब क्या है कि एक्सेलरेशन एंड डिस्प्लेसमेंट आर ऑपोजिट इन डायरेक्शन। ठीक है, तो यहां से फिर वो कहते हैं कि एम्पलीट्यूड और फ्रीक्वेंसी बताएं। एम्पलीट्यूड तो आपको नजर आ रहा है कि वो कितना है जी, 2.8 सेंटीमीटर्स। और फ्रीक्वेंसी का फॉर्मूला अभी मैंने आपको बताया बच्चों, 1/2 पाई अंडर रूट ऑफ नेगेटिव ग्रेडियंट। तो आप ग्रेडियंट की वैल्यू निकालें, इसमें पुट करें और आपका एम्पलीट्यूड आ जाएगा। ठीक है बच्चों, बस पहला टॉपिक भी खत्म हो गया आज का।